Oh, hello, everybody. It had been a little bit of time. Welcome to PerfBytes. I am a PerfByte, one of the four members of the PerfBytes. Actually, you'd think a byte would be 8 bits, so there should be 8 of us. So we really need 4 more people to join us here in PerfBytes land and doing very, very cool stuff. My name is Mark. I am the a performacologist here at PerfBytes. And today's topic, I want to talk about something that my amigo Leandro and I talked about called Rendezvous, and what a rendezvous is and how I use it and how incredibly important it is when it comes to testing super high concurrency within your load test. Of course, I'm going to give a shout out to the various sponsors of PerfBytes as we get going on this. Well, the rain just started. I guess technically it's hurricane season here on the east coast of the United States. So there could be a hurricane right now. I don't think so. Anyway, but it's raining, so you're going to hear some raining, could be some thunder and lightning and things like that. And the dog is kind of freaking out, but that's fine. Special thanks to our sponsors, of course, right down the list, starting with Tricentis. And before they joined Tricentis, our longtime partners, Neotis and Flood.io, who are now owned by Tricentis and doing fantastic, combining all sorts of cool stuff. There's actually some really great stuff that came out recently around load testing. And even though we have this love of digital experience management with our other sponsor, Catchpoint, for APM, Tricentis has some monitoring stuff as well. But speaking of Catchpoint, Catchpoint APM, or digital experience monitoring, so you've got RUM monitoring, etc. Check out Catchpoint, and they do some more innovative. There's actually some new stuff coming that I'm kind of spying on about a web page test and the things that they're building into really, really good understanding of web performance in that area. Speaking of really, really good understandings, our other partner, Folk Consulting, Ryan Folk of Folk Consulting, have a tremendous business helping you be successful with all of these totally complex tools, practices, and all sorts of things. There you can hear the rain happening. I hope it's not too loud. If it, we'll see in the background, that's fine. But Folk Consulting, they will rain their expertise down on your teams and help you succeed and be successful. So I'm kind of psyched about that, Ryan Folk and Folk Consulting. And of course, there's probably people I'm forgetting. Hey, Henrik is online. Speaking of which, you can actually, it's very late in France. It's probably late at night, Henrik. So thanks for joining. I'm going to talk about rendezvous, and maybe you could tell me the French origin of the word rendezvous in the chat. That's a live chat. You can live chat me. We'll see some things that come out over here. If you're on Twitch, I think I do Twitch, LinkedIn, Facebook, etc. Abstracta is another one of our partners. We're behind on getting some podcasts out. I know Federico has been hanging out with Leandro on some of the channels. And the YouTube, if you're seeing Leandro he was at Star Conference, I think he's at a handful of other conferences that are pretty cool, and he's got a bunch going on in his new job. So that's pretty cool. So he's been interviewing tons of people. So head on over to, if you haven't been to the YouTube, subscribing in the PerfBytes channel on YouTube, check that out as well. Wow, it's really raining. That's amazing. So, hopefully I don't think the rain interferes with packets flying down the wire. But if it does, you'll be the first to know. That's very exciting. So that's, let's just dive into this topic of a rendezvous. And Leandro and I were talking recently because some of the tools for generating load don't actually include this idea of a rendezvous. And the metaphor that I used was like a chairlift operator. And a chairlift operator, if you've ever been skiing or on a chairlift, there's like a cable that comes in, and the different chairs are coming in, and they the cable kind of goes around the circle, and it heads on up the hill. So this is up to go skiing, and this is down. And the idea is that as a chair, let's say there's 4 seats available on each chair as they're coming in, and there's 4 seats available, and the waiting line to get on the chair, there's like all the people stand in line and there's kind of a gate and whatever. And so as each chair comes by to get those different people in there, if there's a line, let's say there's a line of people coming in and there's a stream, like you get lined up, etc., and maybe you have 4 skiers, 1, 2, 3, 4, that are ready to go. So as the chair moves around, you would have these 4 skiers. There's a little guy right here, a little person. I'm going to say a smiley face, he's got a hat on. That's sort of a cool ski bum kind of hat. Shout out to Justin I worked with, who was a ski bum for many years. This little chairlift operator guy would ask these 4 people to step up in line, 1, 2, 3, 4, and then as the chair comes by, you actually, all 4 people go together. So you can imagine if it's not very busy, you might just have one person step in line, and they only take up 1 chair, 1 seat on the chair. And so that's the same idea of a rendezvous. So I'm gonna set this a little bit to the side. Actually, I'll just put it over there. I'll come back to that in a second. Basically, a rendezvous is a way to concentrate load during a load test. And if you have, let's just say there's some kind of a function, and you have, let's, for argument's sake, making web requests, web request number 1, request number 2, request number 3, and request number 4. 4 requests. And it could be something like you shop for something, then you add it to the cart, then you fill in the information, and then you finally hit the buy button here on step number 4. And you guys would get the idea that in a load test script, usually that'll iterate. So you'll do n number of iterations of this 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And if you ramp up a load test, kind of slowly over time, and then it gets running and it's going, basically you have each individual virtual user, whether that's a thread. In some tools it's a thread, in other tools it's not. But you have like a session, and it loops the session. Sometimes at the end it'll kill the session at the very end, start a new session. But they're sort of all randomly, there's no real constant, just this guy's doing 1, 2, 3, 4, 1, 2, 3, 4, all these different virtual users doing 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. These different requests. But let's say we wanted to increase the amount of concurrency. Like in concurrency, think about computers, like we want requests for number 4, the buy button, right? Click here to purchase, right? Buy now. Let's say we wanted to concentrate load versus, if we ramp up and this just gets to say 50 transactions per second, not a huge number, but 50 transactions per second humming along, but we wanted to do some extra concurrency. Like we want to make sure that the buy button within the same 1 or 2 milliseconds, we actually got a concurrency of 10 requests stacked up on request number 4. And again, this could be 1,000 virtual users. So we got 1,000 threads, 1,000 virtual users or sessions kind of humming along, doing all their different stuff. But we want this concurrency of 10 because we're really interested in potentially thread blocking, some kind of thread contention. Could be memory contention of some kind. Maybe we're looking at database resources, deadlocking contention, a locking contention, where if you have requests that happen in the exact same microsecond, meaning like in time, if you've got request A, and you've got request B, and you've got request C, and you've got request D. So at one given point in time, like these 2 requests, you see they overlap in the same time slice. That one sort of ends before that one begins. So the only real concurrency happening in any given one interval, meaning let's say these were all 100 milliseconds, we have maybe 200 milliseconds. It looks like 2 intervals. Let's call that 200 milliseconds. There's 100 there and 100 there. And so for 200 milliseconds, we have some kind of overlap between this request and that request. But the Z request is completely weird, and this Q request is completely separate. But let's say we wanted to concentrate those so they happen all in the same 100 milliseconds. In the old load runner world, it was LR_rendezvous. In other tools, it's also called rendezvous. What you do is you sort of put, you can look this up. You could see a rendezvous, and you give it a name, like this is my by rendezvous, and you give it a number of the number of virtual users, and then sometimes you can give it a timeout. So let's say 10 seconds, we're going to time out, right? Something like that. You put this function right before request number 4, and what it does is it sort of pauses the first virtual user that comes there, and so the first guy comes down the pipe and says, "Oop, I got to wait." And it waits for 10 other threads. Here comes another one, comes another one. Now there's 2 or 3, 4 people at the party and another virtual user. So finally we get 1, 2, 3, 4, and we get 10 virtual users all waiting at that rendezvous point in the script. And as soon as it fulfills the criteria or the definition of that rendezvous, now that there's 10 virtual users, all of those guys go boom and hit the buy button at the exact same time. And they can do it because computers are fast. They could do it even within a given millisecond. So you could be very, very specific about how you do that. With a healthy load generator, you could put that together. Here's the couple nuances. One, if you have 1,000 virtual users running, that means groups of 10 will stack up. It won't really, you could make the rendezvous 1,000, which means all requests stack up and 1,000 requests happen in the same millisecond at that request number 4, which means you'll have varying response times, timeouts, maybe it's too much concentration of load, and it'll actually synchronize all of these requests. In fact, the name of a rendezvous in like the JMeter world is called a synchronizing timer. So it synchronizes those. If you do a lesser number, like here I'm just doing 10 at a time, they're like little groups of concentration, little clusters of concentrated load given a healthy number of sessions or number of virtual users. The other thing is this timeout time. Let's say much like the chairlift. Remember in the chairlift, what if things are not very busy and there's just, I'm gonna do it a different color here, I'll do it in pink. Here's one little lonely skier who shows up and is sort of sitting here waiting just by themselves, one little virtual user session, and the chairs are coming, you know, by, like, well, you know what, I might as well just get on and I'll just be the one little chair, and then of course that chair is just that one guy going up the hill. So you don't really have that. There could be a timeout because again, the chairlift moves fairly slow down here at the bottom of the hill. So this is going very slowly. And the idea that I'm not going to wait around more than 15 seconds for another skier to show up. So let's say, you know, here pink session skier number is getting on the chairlift, and all of a sudden, here comes, oh, wait for me, I'll get on there, and then they're a little bit late. Well, this will be the pink chair. Guess what? You know, there's the blue guy ends up being the only guy in the blue chair. But if there's enough traffic, it'll fill every chair, right? Or every request number 4. So that's my skiing analogy for rendezvous. And so in your script, you can put a synchronizing timer. If you were in JMeter, you would do a synchronizing timer underneath the sampler or within that same tree, that position in the tree. In Load Runner, you put and I think in NeoLoad as well. Actually, in a couple other tools, there's a rendezvous that happens right in the middle, right before the request you want to concentrate on or have concurrency on. So it's a LR rendezvous, and you usually give it a name, so you can have different rendezvous with different names, and you could have the fulfillment or the requirement for that rendezvous, number of sessions or number of virtual users, and then a timeout, because you don't want them to sit there indefinitely. Now, the two things I can tell you about this concept, usually not a lot of people use a rendezvous. They just fire up the load, or they run with such little pacing or think times or delays that they're humming along, 250, 300, 800, 1,000 transactions per second. They're like, the whole test is really concurrent. I don't need to do a whole bunch more, right? So they don't use this. Now, those are for usually really big load tests in larger environments or in production, which if you can get away with it, There's nothing like testing in real production. Middle of the night, you get some permission to set up the simulators and you don't use live data, live traffic. You can actually blow up a production system or do it in the DR site when it's not being used. Beautiful. Absolutely, highly suggested. If you can test in production, do it. But when we're shifting left upstream in development, we're working in QA or dev, smaller environments. Maybe you only have one machine instance or something. I'm usually running really small load tests, something like 10 threads. Maybe they run as fast as possible. They run pretty fast. Maybe they don't have high throughput overall because the systems are not very scalable in QA or dev. But one of the things that developers can do really early without running giant load tests is say, oh, I've got thread blocking at a very, very small level. And I've had success helping developers go, oh, well, there's no reason we need to do that, right? A rendezvous, technically, from a load perspective, look up definitions for a mutex, a shared or critical section, meaning locking, like two pieces of code can't pass through. A semaphore is another one. A semaphore object, like a way for controlling traffic flow or controlling logic flow. So looking for mutex, critical section, or semaphores are the programming concepts behind a rendezvous. Well, those are the same concepts that you would find within threads or within a data model that has to be locked or blocked, some exclusive access to certain components or objects. And so there's some locking and or blocking that can happen within the data structures in the app, within the components themselves, the objects that are flying around. Also establishing a session, and most importantly, the database, obviously locking, blocking, and the worst case would be deadlocking, which again could be logically found very, very early. You don't need huge load, but you do need concurrent load. So you could take a small number of virtual users in QA or dev, but run them very concurrently. So if you're only running 10 threads, set that rendezvous to be all 10 and give it a fairly long timeout. So as it comes around through those different pieces, request 1, request 2, request 3, request 4, boom, 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 all 10 of them, bam, every time. But you're running in QA, you're running in dev, so you want highly concurrent stuff. The other thing is to configure in dev and QA some kind of CPU profiling or thread profiling. You might run the application under test, system under test, the app itself, the component, with some sort of profiling happening when you see this. So you can see this object is actually waiting on exclusive access to that object. And you might have a queue of 2 or 3 different requests all waiting on thread number 22 to stop, to release that object and do something else. So there could be things, and of course you're looking at different threading architectures as well. If you're using task-based programming, you're firing up a bunch of asynchronous tasks and the threads are free to go. Well, asynchronous tasks are not always treated equal, especially if they make I/O requests, because at least in the Windows world, also in the Unix world, something needs to stay to hold a socket open, to hold a file descriptor open, same thing. But the idea that you have something happening within the system, you can't just go off in the ether without a thread to manage that or make the callback itself. So even if you're in the asynchronous world, it's even more interesting to see what happens under super high concurrency or super high load. And that's a rendezvous. Again, look it up in your test tool of choice. If you don't have a rendezvous, just try to run small load really, really fast. And there may be some other tricks you can do. There is some other techniques, especially if you're looking at other testing tools that are written, like K6 is written in Go. You could use the programming constructs of Go or JavaScript to be able to build your own mutex, a pause or a delay in there. If you're in JMeter, it's a synchronizing timer. But it's not commonly used, maybe 10% of the time. Sometimes I just run general kind of load without rendezvous or synchronizing timers. But when somebody says, hey, I think we're really interested in finding concurrency issues or some thread blocking issues over in these components, I'm like, what request is that? Okay, let me start adding some rendezvous. We can concentrate the load on that particular component. And that's my advice around rendezvous. Now, I know there's some cool things that might be coming along the way with my friend amigo Leandro on this topic of rendezvous. And I think we've tossed around some ideas of sort of super rendezvous. The other thing is, I use a tool called Montbank, which is sort of like a reverse engineered load generator as a simulator, right? So it's an imposter on the back end, a responder. So rather than generating load, it's responding to load. And I thought, there should be a bursting thing. So if I look at some queuing and then a burst of responses from a remote service in your service virtualization, ITKO, Parasoft, you name it, these fantastic service virtualization tools, it would be for game day scenarios where all of a sudden a processor, like all of a sudden everything disappeared and then boom, it responded with all of my responses came back because there was some queuing or some problem on the network between us and them. In the service virtualization world, I think a rendezvous is actually almost more important because your system under test is innocent, as innocent as it can be, and those big bad external internet-based services are unreliable. Well, this is a great game day scenario to say, what if that remote service, wakes up, runs a bunch of stuff, and then goes quiet, and then boom, hammers back at us a bunch of responses. So look for some cool stuff. I'd like to see that rendezvous make its way over into Montbank. So shout out to the guys at Montbank. Yeah, that would be really, really cool. A shout out to Arlene, made it, Henrik, of course, Anil, everyone from Dallas, Texas. My thoughts go out to everyone with the school shooting that happened down there this week. That's incredibly sad, and a lot of people are frustrated and angry. So my efforts to support change will not abate. So I'm not a big gun guy myself. So. Shout out to everyone who has very responsible techniques and doesn't believe that anyone needs assault weapons, because I certainly don't. You know what everyone needs? Not assault weapons. You need rendezvous in your load tests. Shout out and a thank you. Follow us on PerfBytes on Twitter, on Facebook, on the socials. We're pretty busy. There's a bunch of stuff down below in the comments about you can link to Henrik's Is It Observable? The Spanish version, Español version with Señor Performo, amigo Leandro. News of the Damned, of course, the last time I gave James a bunch of crap for not doing News of the Damned, I was completely sick that weekend, and he did a News of the Damned, and I was out. So someday we'll get back together and do stuff. So apologies for that. But James still does the News of the Damned. We do have an Ask Us Anything that happens at the end of every month or the beginning of every, I don't know when it happens, but it's much like the live chat we have here. You can ask questions, and I look for some social postings on when the next Ask Us Anything about performance or barbecue, or we usually end up talking about cloud stuff. We have a couple great questions here and there, and there was one great question from Trisha about testing batch jobs, ETL. I think I'll table that one again for next time. I gave a little answer. But I think there's some more elaborate understanding that we can have about that kind of stuff. Thank you guys very much for watching and listening. Have a safe Memorial Day weekend. And we'll see you next time on a little bit of the PerfBytes. All right? I think it's going to